I will start with an intro about the scientific project towards smart ventilation in mid-sized buildings, from where the results came from for today. And one of the results that will be presented by Klaas de Jonge from Ghent University in Belgium is about an economic holistic indicator for assessment of smart ventilation systems. And then our next speaker will be Doua Alassad from KU Leuven in Belgium, and she will explain you more about the quantitative assessment framework of IQ resilience in buildings, so another indicator. Then we move on to the design. Zakaria Cabarra from University of Antwerp in Belgium will explain you how to design a simulation-based design of smart ventilation systems. And Joris van Herwegen from Buildwise in Belgium will end with improving the supplied ventilation air quality through filtration. And of course, not the end of the webinar, because we will end with some questions and answers. I will lead you to the wrap-up of this project, so to give you the framework of all these results about smart ventilation. It was a project that we did together with 4 Belgian partners, KU Leuven, Ghent University, University of Antwerp, Buildwise, and also the partner from the Netherlands, the TU Eindhoven. But it was not only research institutes, there were also a lot of industrial partners involved, like you can see here, and they were from design over development, manufacturing, installation, through maintenance. And what did we do together? We start from the following. I think all of you know the definition in AIVC of a smart ventilation system. It's able to continually adjust itself to provide a good indoor air quality while minimizing energy use, discomfort, noise, and so on. It's also responsive to, for example, occupancy, outdoor thermal and air quality, and also can provide a lot of information. But we all know this is still now theory. In practice, we see in the design of ventilation systems, most of the design is driven by minimum requirements for one of the factors for energy or IQ. And especially in mid-sized buildings, we see very conservative and inefficient designs just based on the brain power of our, of course, smart engineers. So what did we aim and what were our goals? We wanted to determine a performance-based method for smart ventilation design and driven by optimization during the whole life cycle. And you see some specific goals, and that is also you will see it in the presentations. We started with definition of performance sub-indicators for indirect metrics, like, for example, sleep comfort, also resilience. And then we aggregated all these sub-indicators together with other existing indicators in one general economic performance indicator. This one is then used to optimize the aerobic layout of the ventilation design. And we also try to improve and optimize the positioning of connections and also the filtration. And as I said before, the focus was mid-sized buildings, but I mean an airflow rate more than 1,000 cubic meter per hour, but it's both in new and renovated buildings. And we had examples of a school building, offices, and care facilities like elderly care homes. So as I said, 2 parts. The research method was performance assessment. So you will see together with us all and the presentation of Klaas on the economic performance indicator and the other presentation of Doua on resilience. But like you see here, we also had a topic on occupant-centric design, the satisfaction of the occupants, the acoustic performance, because it's also important, usability of heat recovery, and also a sub-indicator for sleep environments. And for the optimization of design, we split it again into 2 parts about the air distribution system. So there we have the simulation-based design that Zakaria will present to you. But we also had a CFD part about improving the predictions of the pressure drop in ventilation systems, and a part about the acoustical design. And on the right-hand side, you see about the positioning of the openings and filtration. Joris will present us about how to improve the supplied ventilation air, but there are also interesting parts on optimizing supplied ventilation air through the positioning of the openings, and also simplified CFD to optimize the location of the ventilation opening. But that will be part maybe of a next webinar.